Okay, the first thing that you need to do today is open up your table of contents and put in this entry. So today is January 26th. Our topic is ratio tables, and that's going to be on page 42. Now, as I go through this video, if you need to pause the video before you move on, just pause it and then press play when you're ready to move on. So once you have this in your table of contents, go ahead and turn to your next blank page, and you're going to glue the two sheets that your homeroom teacher is going to give you. If you haven't gotten those yet, make sure you get those from your teacher. So you're going to glue the practice problems on the left and the notes on the right. So go ahead and pause the video until you have those glued in, and then when you're ready, we're going to get started on the notes. So the last couple of days we've been working with ratios. We're going to continue that today, but we're going to look at them in the form of a table. So let's talk about what a ratio table is. A ratio table is a list of equivalent ratios. So when we were simplifying ratios the other day, we were making equivalent ratios. And so anytime it's like when fractions are equivalent, ratios can be equivalent too. And those equivalent ratios can help us understand the relationship between the two quantities being compared. Remember that a ratio is just a comparison of two quantities. So the ratio table can help us understand the relationship better. And they're very helpful in making predictions. They can help us make predictions. So for example, a recipe could say that there are 3 teaspoons of sugar for every 2 teaspoons of flour. So this is a ratio, 3 to 2, sugar to flour. But sometimes you make a bigger version of a recipe, sometimes you make a smaller version, and so you might be using different amounts. So we're going to make a table about this relationship. So let's start with the original numbers, which was, let's go ahead and mark this. It's 3 sugar to 2 flour, and in the table it is sugar to flour. So remember that order matters. So 3 to 2. Now we're going to make some equivalent ratios out of that ratio. So let's say we wanted to double the batch. So write times 2 times 2. If you're going to double the batch, you have to double not only the sugar, but also the flour. And so if I double 3, that's going to tell me I need to use 6 teaspoons of sugar. And if I double 2, that tells me I need to use 4 teaspoons of flour. So 6 to 4 is an equivalent ratio to 3 to 2. Now we're going to say maybe we want to triple the recipe. So write times 3 times 3. So 3 times 3, and be careful because we're not tripling the 6, right? Look at these arrows. This is coming from the 3. We're always starting back with our original ratio. So 3 times 3 is 9, and 2 times 3 is 6. So 9 to 6 is another equivalent ratio. We have to keep these ratios equivalent for our cookie recipe to taste right. If you were to, let's say, triple the sugar but only double the flour, your cookies aren't going to turn out right. Okay, and then in the last one, we're going to do times 4 times 4. So 3 times 4 is 12, and 2 times 4 is 8. So 12 to 8 is another ratio that is equivalent to 3 to 2. Now we're going to talk about making those predictions. So it says, based on the relationship shown in the table, let's predict how many teaspoons of sugar. So we don't know the sugar. We would need if we used 42 teaspoons of flour. So 42 is for flour. So what I'm going to do is I'm kind of just going to add that to the bottom of my table here. So the 42 would go here. And I don't know why I wrote 14. Don't do that. 42. Okay. So I'm going to put 42 there. And I'm going to put a question mark here for sugar because that's the one we're looking for. Okay, so we could start at the very beginning and we could see what we would multiply 2 by to get 42. You might know that, but it's a big number. So that one is one that you might not know. What I think is helpful is to look for one that you do know. So as I'm scanning down, I notice that I know what 6 times something equals 72. That's one of our math facts. So when I see 6, I know 6 times 7 is 42. That means that I can also take 9 and multiply that by 7. And so basically I'm looking at from here to here is times 7. So I can go here to here times 7 to help me make that prediction. And I'm running out of ink. Let me grab another pen. So 9 times 7 is 63. So that means I need 63 teaspoons of sugar. And again, we could have gone all the way back up to the top because 2 times 21 is 42 and 3 times 21 is 63. So we'd still get 63, but it's just not, you're more likely to know what 6 times something is 42 than 2 times something. So you don't have to necessarily go back to the beginning. You can find anything in here where you see a relationship. Let's look at some example problems so you understand how this could be tested. So problem number 1 says, Rachel is riding a train to her aunt's house. The train travels at a constant rate of 55 miles per hour. So when it says 55 miles per hour, put a little 1 by that. That means 1 hour because there's no S on the end. Which table represents the relationship between H, the number of hours Rachel travels, and D, the distance she travels over a certain length of time? So 1 hour is 55 miles. So this right here looks good. 1 hour, 55 miles. On B, it says 2 hours and 55 miles. So that's not right. So it doesn't even matter. I'm not going to look at the rest of them because I know that's not right. D also has 1 hour and then 55 miles. I think I said minutes a minute ago, but that's miles. And then this one has 1 hour and 45 miles. So that's wrong. So I'm going to get rid of that one. Okay, so now it's between A and D. So I need to understand if the relationship is right. So 1 times 3 is 3. So if that's correct, then 55 times 3 should be 165. So I'm going to test that out to the side. 55 times 3 is 165. So that one's good too. And then this one is times 5 times 5. So let me check that. 55 times 5 is 275. So that one also comes out right. Now I can see right here, 55 times 2 is 110. And right here, this is times 4. So it's not using the same relationship. So the only one that kept that same equivalency, the same relationship through the whole problem was A. Number 2 is about paint. So you can mix blue paint and red paint to make purple paint. So this says she mixes 8 cups of blue to every 5 cups of red. And we want to know which table shows that same relationship. So 5 blue, 8 red. This looks good. This says 8 blue. Oh, nope, I just messed up. 5 blue, it's 5 red, not 5 blue. So these are switched. Okay, so obviously that's an easy mistake to make because I almost made it. But then I noticed all the rest of these have 8 to 5. It was 8 blue to 5 red. So this one looks good, this one looks good, and this one looks good. Here we have times 2 times 2. That looks good. Here they switched them. We can't switch the order. We said order matters in ratios, so I'm going to get rid of C. Here we have times 2 times 2, so that looks good. Here we have times 3 times 3. That looks good. Here we have times 4 times 4. That looks good. So these two both are looking good until the very last one. So we need to see which one is wrong. So here we have times 4 times 4. That looks good. Here we have times 8, and then we have times 5. So this is times 8, this is times 5. That's not the same relationship. So D is not our answer. But B kept that equivalency. Just so you know, your assignment today will have tables like this, but it will have missing numbers, and you'll have to fill it in. So if you had the 16 missing here, but you had a 10, you would know it's times 2, so you would do 8 times 2 to get 16. Okay, so we're going to use that last table, the one that was correct. Notice I added an extra column on the end because we're going to predict how many ounces or cups of blue paint we would need if we needed 100 ounces of red paint. And so we could start from the 5 and figure out what we're multiplying by, but I wanted to remind you that you could use any of these. Do you know what you multiply 20 by to get 100? Great, do that. Do you know there's nothing we can multiply 15 by to get 100? Do you know what you can multiply 10 by? That would probably be our best bet. And do you know what you can multiply 5 by? Any of those would help us. So the one I noticed was I know what I could multiply 10 by to get 100, because 10 times 10, that's a common math fact. 10 times 10 is 100. So if I do that, then I'm going to do the same thing up here. So I do 16 times 10, and 16 times 10 is 160. So I would need 160 cups of blue. Okay? So if you need to finish writing anything, go ahead and pause, but I did want to show you what your assignment looks like today. So you're going to see tables like this. They look like what was on the practice, but there's missing numbers. So I notice here 12 times, here I'll go ahead and write on it. 12 times 2 is 24. 1 times 2 is 2. Here we don't have what that number is going to be, but I notice here 1 times 3 is 3, so we must be multiplying times 3 here. So I would put 36 in that one, and let me just show you what that's going to look like. When I type in 36, it's going to turn a color. If it doesn't turn a color, like let's say I had put in 3 on accident, it stays white. So if it stays white, that means it's wrong. So you want it to turn a color. And then on this last one, 12 times 4 is 48, so we're going to do 1 times 4, which is 4. Okay, so hopefully this makes sense to you. Email me if you have any questions, and good luck today.